Okay, so this is part 2 and 3 of solving systems using elimination. So in the previous video we talked about when a term already cancels out. In this one we're talking about when they don't cancel out. So I can't add 2 and 10 and 5 and 3. I can, but I'm still dealing with two variables that don't cancel out. So I need to make it so that one of the variables cancels out so I can solve for the other one. So the way we do that is we have to multiply by a number. So we have to increase the factors of one of the equations so that when I multiply it through that it cancels out with something else. So there's so many ways you can do this and where you could get things canceled out. So but this is like using if we only have to manipulate one. So when I look at this particular example, I need to make either some of these, either the x's or the y's, opposite of one another mathematically, meaning by multiplying by some number. The thing that stands out to me right here is if I can make this somehow a -10, then it would cancel out. And we do that by multiplying 2 by -5. So that's one way that we can figure out how to do that. So if you look at this, I would multiply every term by -5. So what that does is -5 multiplies by 2x and becomes a -10x. -5 times -5y becomes a -25y. And then -5 times -22 becomes a +110. Then I have this original one underneath, and now look what happens. I can now combine all of these terms. The 10s will combine to equal 0, so those are gone. -25 plus 3 gives me -22, and 110 plus 22 gives me 132. Then I can subtract 22 from both sides, or divide 22 by both sides, and I get y equals 6. All right, so we are at the point here. So this is basically step 2 that we did over here in our previous video. And again, once we do that, we put then our variable that we solved for, could be an x, could be a y, depends whatever works out the nicest. And we have to put that into one of our equations. We can use either of these two equations. We could even use the one that we manipulated if we want, but usually we go back to the original two. In this case, I like this because it's smaller numbers. But again, I showed you using both of the equations how if we put 4 in for y, remember not x because we solved for y here, how we would get our answer. So if I put that 4 in for, or -6, this should be a -6 because I made a misprint there. So we put the -6 in for these, and then we solve for our answer, which would give us x equals 4. So this kind of just walks you through that process. 5 times -6 is -30. Add 30 to both sides because we're getting the 2x by itself. That would be 2x equals 8, divide by 2, and we get x equals 4. So 4 -6 is our answer for that problem. All right, so we're going to do a couple sample problems. I always feel like it's easier just to go through and walk through these problems and do some sample problems than the explanation. But hopefully you can see that process as a reference when you're doing these problems. All right, so these were the problems from the other day. So down here, we're starting with step 1. Whenever we have just unit rates right here, I mean, we have an option. We can multiply this by -1 to get the y's to cancel out. We can multiply everything here by 3 to get -3 to get the x's to cancel out. It's really personal preference as far as how you want to tackle this problem. I'm going to go ahead and multiply this whole thing by -3. Just because I think when students are first learning this, they look at that first term and want that to cancel out first. All right, so what I do is I multiply this -3 by that x. It gives me -3x. I multiply the -3 by the positive y. That'll give me -3y. And then that equals, and I multiply the -3 by the 12. That's going to give me -36. All right, now I'm going to write this other equation right underneath it, and look what we have here. 3x plus 1y equals 20. Now I go ahead and I can combine these terms, right? So if I combine a negative 3x and a 3x, that's 0. That was the whole point of doing that. Negative 3 plus 1y. So negative 3 plus 1 is negative 2y equals, and then negative 36 plus 20, and again, use your calculators on these. So negative 36 plus 20 is going to be negative 16. And my last step is to divide by negative 2 on both sides. So I get y by itself. Y equals negative 16 divided by negative 2 is positive 8. All right, so there's half of my problem. Now I have to solve for x, right? Because I need two answers. Well, what I'm going to do, just because I think it's the easier problem, I'm going to use the x plus y equals 12. But instead of y, I'm going to substitute in 8 because I know that y equals 8. So I'm going to say, I'll use a different color here, x plus 8, that's my y, equals 12. Then I can subtract 8 from both sides. And I have x equals 4. So there's my ordered pair. I have a 4, 8 is the solution to that system of linear equations. All right, over here, again, you have to pick a number that you're going to multiply one of them, and in the next section I'm going to do another video where we might have to multiply by both of them because it doesn't work out nice and neat. But over here, we can multiply one of these to make it cancel out. So if I want to make the x's cancel out, I would have to make this a negative 3 by multiplying by negative 3. If I want the y's to cancel out, I can multiply everything by a negative 1. That would make those cancel out. All right, so it's, again, personal preference of how you want to do this. Let's multiply by negative 3. Just because I think that stands out to a lot of people here. Even though you see this, it's like, oh, I got to do the opposite, but let's just go ahead and do this. So we're going to multiply everything in this by negative 3. So this becomes a negative 3x. This becomes a negative 6y equals, and then negative 3 times 9 is negative 27. And use your calculators. I mean, you should have that calculator out and you're just doing the math right along with it. All right, now this second one I'm going to write underneath. If you do the first one, you can write it right underneath and you can kind of see how they're lined up. But for the sake of the notes, I'm going to rewrite it underneath. So we have the 3x plus 2y equals 7. All right, now we're just adding. We're going straight down. Old school addition, top to bottom. These cancel out. Negative 6 plus 2 gives us negative 4y. All right, and negative 27 plus 7 is going to give us negative 20. I divide by my negative 4 because I'm solving for y. I got to make that equal a 1. All right, so divide by negative 4. And I get for my final answer, not my final, I guess it's half of my answer, y equals positive 5. All right, so there's my y value. Now I have to solve for my x. You can use any of the terms, right? You can use this problem or this problem right here. It's up to you. I'm going to use the x plus 2 equals y. So let's go ahead and put the x plus 2, and then, did I say x plus 2 equals y? I meant 9. We're substituting this 5 in here, so because that is a 5, y equals 5, we're plugging it in for that, equals 9, and we do our math. So let's rewrite this as x plus 10 equals 9. We're going to subtract 10 from both sides so we can get our variable by itself. Do those opposites. And we have x equals negative 1. So my ordered pair would be negative 1, 5 for my answer. Again, you guys can use the Desmos calculator, right? So we can take, let's see if it's still up here. We can use our Desmos calculator to check for our answers. So if you type these in, we should get the correct thing, or it should match up. So 3x plus y equals 20. And then under here I have x plus y equals 12. Look at that. 4, 8 matches up. Wonderful. We did the math right. Sometimes I record these and I realize I made a mistake, but I don't realize it until I check my answer. Then I have to re-record them, but sometimes I leave it up there just so you guys see that I can make mistakes too. All right, so over here, x plus 2y equals 9. So there's that line. Then we have 3x plus 2y equals 7. And where do they intersect? Negative 1, 5. Good. We did it right. This is kind of cool to point out. The problem we manipulated, the x plus 2y equals 9, like how does that work? We take the negative 3 and we multiply everything through. Because we're increasing everything by a factor of negative 3, we're actually not really changing the value of it, right? Since we do everything by negative 3, we're just increasing it by a factor of negative 3, which essentially makes it the same thing mathematically. So let's take a look at this. Negative 3x minus 6y equals, and now watch the line over here, negative 27. You see how it just popped right back on there? See that? So if I put the 27 in, it goes right on top of it. And that's how we know it has the same value, which allows us to manipulate things in math. So, you know, when we kind of understand that, it makes it so you can make math work for you to be able to figure out different things.